have a short discussion about slope. Okay? Now, lots of different things we can do with slope. First and foremost, though, I want to have a discussion about what is slope and how can we use slope, and how does it relate back to, say, density, which I think is, in some respects, is actually a slope in some respect. You'll notice I have this set up, so I'm having both of them point to the fact that density is a ratio, slope is a ratio. The difference between slope, generally speaking, and density is units. Okay? If you have a density, you're talking about stuff over space is the non-technical way to define that. There's a far more precise way we can define that idea, but this is, I think, a good working model. It's actually mass over volume is the correct formal definition of density, but it doesn't have to be mass and it doesn't have to be volume. It can be stuff over space. And I use space. I should even take space there and put space in quotes, because sometimes it's not just talking about a space. Maybe you're talking about a city, people per city, which could be a density, right? You're talking about potatoes per bag. The bag is technically a volume, I guess, but you're not defining the bag as volume in of itself. You're defining it as volume, or as a thing. How many apples, how many potatoes, or whatever are in that bag. How much dirt can we fit in the back of the truck, which again would be a density. So that would be mass over space, but you're kind of loosely defining that space. So my point in saying all this is that when we talk about density, we're normally referring to something that is countable over something that is countable. And these have some type of units attached to them. Now slopes, a lot of times we don't really worry about units at all with slopes. But they can have a slope. They can have units. But the primary definition of slope is rise over run. Now let's talk about this for a second. How do these two pieces relate? So we just go ahead and draw our standard XY coordinate grid. Okay? We have our independent axis, which we normally call the x-axis. And we have our dependent axis, which we normally refer to as being our y-axis. Now I say normally in both respects because there's nothing definitively saying that the x-axis has to be the independent axis. Typically we make the horizontal axis our independent axis. So when we talk about, say, time would be an independent variable most of the time. So we normally put time down here and then something else up here. Like for instance, let's say that this x-axis here is time. And then this y-axis over here is distance, which are both measurable, right? So this time can be measured in hours, seconds, whatever. This distance here can be measured in feet, meters, whatever. Okay, so we have a distance that is being measured, we have a time that's being measured, and depending on what our applications are, those two things would change quite a bit. If we're talking about continental drift, this might be centimeters per century. Okay? If we're talking about a car going down the road, this might be miles per hour. If we're talking about a baseball flying through the air, we might be talking about it being feet per second. If we're talking about somebody running down the football field, it might be yards per second. So depending on our applications, it's going to change our units based upon what we're trying to understand and learn about this. So let's just say that we have distance covered and the time that's elapsed. So it starts, and it does this. Well, that's going to have some type of slope to it. Now let's just say the slope is 5 over 4. And what that means is that we would have a 1, 2, 3, 4, 5, and then right here be a run of 4. So it's gone over 4 units while it's gone up 5 units, whatever those units are. In this case, we're talking about a speed. Maybe this distance is being measured in meters, and this over here is being measured in seconds. So this slope here is 5 meters for every 4 seconds. Now we could reduce that and turn that into, say, 1.2 meters per second, which might make more sense, might be more useful. But in this case, the slope idea here is very useful in of itself because it defines the type of movement in both directions and gives us very accurate understanding of what's going on in both movement directions, both in the horizontal and in the vertical, right? We have both of those being defined there. Now, what is interesting to point out here is that this 5/4, by the simple way it looks like, it does actually meet this definition for density. Now, is speed, that's what this is, all right? That we're describing this as being a speed here. Is that speed a density? Is that stuff over space, even in quotes? No, not really. So we wouldn't call our speed a density, although it does technically meet the definition of it being a ratio, this ratio idea between two independent quantities, if you will. And in fact, actually, in this case, it is completely independent of each other. But there is a correlation. There is a relationship between these. As one increases, the other increases. And this would be called a positive correlation or a positive slope. So this is positive slope. Okay, another way we could describe this would be increasing. Okay, and then we have another type, right? Another big type. There's actually 4. We also have something like this, in which case this would actually be what we call a negative slope, or it is decreasing. Now, what would that look like? Well, let's just go back with the same idea with the same numbers. In this case, this slope would be negative 5/4, meaning it's gone down. Right here would be 5, and then let's just say, what do we want to do? I guess I didn't draw that really well, because it goes all the way here. Let's say this spot right here is 4, right? In this case, this would mean it's going down 5 units while going over 4 units, whatever those units are. So we're talking about a speed in this instance. Well, the speed means you're going backwards. Negative speed would mean you're going backwards. We can have lots of applications to this, but this could also, well, could this be a density? Could we have negative 5 stuff per space? And this is when it really starts to point out that density can be a type of slope, but not all slopes are densities. This is, if you will, this is a general, more generalized type of ratio, where density is a very particular type of ratio. We can do a lot of, we can define a lot of things as being slopes. One of those slopes is a density. Another slope that we have now discovered is that speed, or velocity, which just means that we're adding a direction to the speed, is also a ratio, right? So it's distance over time, right? And again, actually, let me do it this way. It's also a ratio, which means it's also a slope, okay? So the idea behind slope is that we have the ratio between two quantities. Those two quantities can have units. They don't have to have units. Depending on the types of units we have, we might have that particular slope as a density, or that slope could be a speed. So here we have, there's that, right? Now, when we start talking about this in different respects, let's do a completely different scenario here other than, say, speed. What if instead of it being time and distance, what if it were plant bed and tomato plants? What are we referring to at this point? Well, we're saying at this point, this would actually be a density. It's no longer a speed, it's now a density, right? And we're saying there's 5 tomato plants for every 4 beds, planting beds that we have. Which, how does that work, right? Well, maybe these are planting beds that you go to the store and you can buy one section, buy another section, you can link all the sections together. And if you buy 4 planting sections, you can plant 5 tomato plants. That would be really useful information to have, because that means that you would have the ability to plant 1 extra tomato plant, because otherwise you're really just talking about 1 bed gives you 1 tomato plant. I don't actually grow tomatoes. I don't know how big these plant beds have to be. That's information that's outside my area of expertise, using that as an example, right? So maybe you're talking about, instead of planting beds, maybe this is acres, and you're talking about, you're measuring this in terms of, say, hundreds. So this is 500 apple trees for every 4 acres. So if we buy 4 acres, we can plant 500 apple trees. Well, if we only have 1 acre, how many apple trees can we plant? Okay, and that's actually a legitimate question. We can plant, if we do the division on this, we discover that division number is 1.25, pardon me, is 1.25, which means that if we buy 1 acre, we can plant 125 apple trees, which is doable, right? But if we're talking about a tomato plant, and we're counting in terms of ones, that means that we can plant 1.25 tomato plants per planting bed. Well, it means we're losing a quarter of a plant. We can't plant that. So if we buy 4 of them, we can get a whole extra plant out of this process, which is more efficient. More money, but it's also more efficient. Can we have the same discussion with the negative slope? Can we say -5 tomato plants for every 4 beds? Well, maybe not that way, but maybe we could say it's in terms of for every 4 beds that we lose from a storm, we lose 5 tomato plants. That's something we could talk about. Okay, so there are ways that we can deal with density, talking about this idea of slope. This is our standard definition of slope, and we're going to talk about that here in a second in a little bit more detail. But this is what we end up with, right? This idea of how we can measure this out. Going back to our prime example here, if we go over to 8, we go to the hardware store and we buy 8 beds, that means we can get 10 plants planted, right? So what if we went to 4 more beds? Well, that would mean that we can get 5 more plants, which means that we can get 15 plants for 12 beds. That same ratio of 5/4. So that allows us to be able to do that. And we can count this in terms of all sorts of things. And you can replace tomato plants and beds with all sorts of things and create that quote-unquote density where you have stuff over space. A lot of times in a physics class or a science class, we're always defining this as mass over volume, talking about the density of an object, metal, some type of metal, or other element or compound that's in a space. How much can we pack in there, right? And keep in mind that there are other mathematical equations that describe as we increase the density, like if we take a gas, and we increase the density, we increase the pressure, we're also going to increase the temperature, which is a whole nother aspect of this. And if you are equipping young learners, if you're a future teacher, if you're equipping young learners with understanding this idea of slope, you're using this simple concept of this density to help reinforce this idea of slope, you're equipping those students to understand a whole range of other things that are going on with slope. So yes, it is rise or run. Now, let's talk about this. Some of you are probably saying, well, that's backwards. It's supposed to be y2 minus y1 and x2 minus x1. Well, I'm going to push back and say no, okay? Here we got the point 0, 0, and here theoretically we would have the point 4, 5, right? All right, so what we're talking about is that we'd have 0 minus 5 over 0 minus 4, which gives us -5 over -4, which is 5/4. Or we could do 5 minus 0 and 4 minus 0, which gives us 5/4. They're the same thing. All right, I encourage you to redo this with other values. Just pick 2 points, subtract them one way, reverse it, subtract them the other way, and what you'll find is there'll be difference. Both of them, the signs will just switch. You'll have 2 signs that you can cancel out, or just move from top to bottom, and you will end up with the same value either way. So it doesn't matter which way you're doing this, because which one is designated as x1 and y1. But you can do this for anything. So if you have 2 points of information, you can create that slope, and if you're talking about stuff over space, that allows you to be able to find the density of whatever's going on there, just simply based upon those 2 points of reference. So thinking in terms of density as a slope allows you to be able to find the density quite easily, just simply based on those 2 points. All right, so I hope this was helpful. I hope you're enjoying math more than you used to. That's always a goal of mine. I encourage you to reach out and ask questions as you have them. Take care.